Hey everyone, so today I'm doing a bit different from what we did for the blockchain development because we're gonna implement a testing. So the testing framework I'm gonna use is called Jest. Um, so this is Jest. So Jest is a testing framework developed by Facebook. What I like about Jest is that it's so easy to configure. I don't need to do too much of configuration to get started. So and then the second another npm library I'm gonna use is called concurrently. So basically I can run a few of the like the TypeScript watch, and then I can run the Jest at the same time. So I'm gonna use these two library for today. Alright, let's get started. So in the terminal, what you're gonna do is because I didn't init, so I'm gonna init it. Oops. So I'm gonna initiate, and then so what I'm gonna do right now is that I'm gonna add in a test file. So I'll write this later. So there's a few dependency I need to install. So I'm gonna add in the Jest, and then I need to add in the concurrently. Gonna add in another dependency is for types for Jest. Then gonna add concurrently. So add a dev flag to save in development mode. So what you're gonna do with the test file is pretty simple. You just need to create a new file, and then for example blockchain.test.ts. There you go, it's done. Just gonna quickly set up the concurrent. So concurrently I'm gonna run tsc-watch, and then I'm gonna run the Jest. And then for Jest, what command I want to use is that I'm gonna use the watch all command. So basically how it looks like is -- watch all. You can double check the syntax yarn just help. Then just gonna grab watch all. Alright, so watch all is watch fast for changes and rerun all tests. So we had this concurrent test set up. Alright, so we're gonna set up our first test. So in the file blockchain.test.ts. Oh wait, I'm gonna check out to the blockchain. Okay, so what I need to do right now is that I need to set up the blockchain test file. Alright, so in this blockchain test, we're just gonna import blockchain from blockchain. Then import transaction. Okay, so just look for the test we need to do. So first we're gonna make this test file. We're gonna copy all this, not using all of them, but it makes sense that to try out a few of the things. So I'm gonna start the blockchain by describing. This is from the blockchain. So what we're gonna test is we're gonna put in the error function. Alright, so how this test works is that I'm gonna describe it, what it does. For example, it adds 1 to 1. It adds 1. So and then we pass in a callback function. So here we're just gonna expect something, expect 2 to be 1 plus 1. This is just a simple test to showcase you guys how you do it. So what you need to do is just run test, and then you run all the tests. I think to equal would be a better syntax in this case. To equal. Yep. So the practice is that you put 1 plus 1 here. Oh yeah, this test file, you're gonna rename it dev test. Okay, quickly just gonna delete, then gonna save it again. Alright. Alright, so you see that the test pass. So in case I make it into 34 for example, you show that the test failed. Why it fails is that the x1 is failed, and then it received is not equal to expected. The expected value to be 34, but I received only 2. Okay, so we can start doing our test. So first and foremost, just quickly go in blockchain class. So what we can do in this case is that we gonna start a blockchain classes. Okay. So here, we're just gonna copy all of this right now, and then in this here, we're gonna add in before each. Then it's an arrow function. Okay, this is a Genesis block. So Genesis block. Then seems good. Okay, so we don't need to do the mining part right now. What we need to do is that we're gonna make it global function bc and t. Okay, so these codes will be run, and then what we need to do first is that we need to check that the previous block is previous block. Okay, so it checks previous block hash to be equal to current block previous hash. Okay, so this can be done quite simple. So what you need to do in this case is that we're gonna add in the new block to be equal to blockchain dot generate next block by passing it into the T, the transaction. Okay. Okay, everything seems good. Oh, get next block. Okay. Okay, so what happened next is that we'll get the new block. we need to compare the new block previous hash with the Genesis block hash. So what I can do is that we're gonna expect the new block dot previous hash to be to equal to the Genesis block dot hash. Okay, gonna save it. Alright, you see that the test passes, so this means that we had successfully checked the previous block. Alright, there's still a lot of things we can do right now. Okay, so the next test we can do is that we can do the Genesis Adplots, so we can check the Adplots function whether is it working. It checks Adplot function. Okay, so we expect that when we add a block, we're gonna have more than one block. Okay, so I can name so this is the new B generated, so I can just let new B to be block data. Okay, so we're gonna do so let current just check the current blockchain dot current blockchain dot blocks. So expect current blockchain dot blocks dot length to be one block less than after you adding it. So blockchain dot add block, gonna add in the new block. Sorry, need to -1. Right, let before BC equal to this, then let after BC equal to gonna run this function, then just need to make sure that it increases the length. So gonna add in before BC, then after BC -1. Okay. Alright, you see that the test pass for all this, because we expect that the before blockchain added, it has, for example, in our case it's like before we add it has only one block, then after we add it has 2 blocks. So 2 minus 1 will be 1, so you get the result. So this is to test the functionality of the add block. Then we can add a few more tests. Generate hash, we don't need tests. Okay, so we done the test for blockchain class. we can add test to block class. So in block class, what we can add is to check this key whether you really get what you expect you to get when you pass in. Then you can add in the transaction test, I guess. And then you can also do API tests with Azure's or API fetch node fetch library. So we're gonna add in a new file, block.test.ts. so this is a test file for block. So we're gonna import the block from the current file. Right, I'm just gonna add some setting right now because it's a bit annoying about all the prettiest kind of thing. Gonna create a .vs code file. So this is more towards how VS Code settings. So create a settings.json. Okay, so I'm gonna just copy down my previous setting because I usually use prettier. So with so what this is gonna do right now is that when I save, it auto formats for me. So you see that all the formattings is done. Just gonna quickly you see everything is done formatting. So I'm using a plugin called Prettier. Okay, so from the block.test, so we're gonna test how the block features work. So we're gonna describe this as the block. Then so we can test stuff up. So we expect that when we use the get key string, we can get what we expected. We need the transaction. Okay. So this is gonna test whether it get the key correctly. Okay, so in this case we're gonna get this key, see whether it gets correctly. So what we can do is that we can generate a new transaction by passing in you, me, and 5. Okay, so we can just console log what we get from key. And we can try out this. So when you stringify, you'll get like something like this. Okay, so I'm just gonna. Okay, so what we can do is that we can generate a new block. So the new block asking me to pass in the first index, and then the hash. Okay, and then the previous hash. Okay, and then the nonce will start with 0. Then the transaction, we just pass in the t in an array. Okay, so they just console log what b.key is. Okay, so we're gonna expect b.key to be equal to So we're gonna hard code this. So with JSON stringify, you get this is the first one. Okay. After that, what we're gonna get is the index. In this case, index is 1. Let me just try something else. 777 666. Okay. So the after the index is the previous hash. Previous hash followed by nonce. So the previous hash is 666. Then the nonce is 0. Okay, so the test pass. Okay. Maybe just leave it here. Okay, so this test pass, what else we can do test in the block? So we can see whether the add transaction is it working. So it adds transactions successfully. Okay, then you can pass in an arrow function. So how we're gonna start is that I think this, since we use it twice, what we can do is that, okay, before all, okay, so we're gonna try to I guess we can also create a new block there. Okay, so b dot add transaction, we can add in t, but before that we can just check b dot yeah, there's a transaction, so we can check let previous transaction to be equal to b dot transaction dot length. Then after we add it, we let the after transaction to equal to b dot transactions dot length. Okay, then we can compare. So expect the after transaction to be equal to previous transaction plus 1. Okay, so we can start the test. You see all the tests is passed. So we carry out 4 tests. So in the blockchain, we tested that the previous hash should be same as the current block hash, and then we test out the add block function. Then in the block test, we test out the add transactions, and then we test out to get the key correctly. Although this seems to be hard coded, but this should be done before we started the project, or maybe in between development. But I forget to add in this testing part. But testing is quite essential to make your codes more robust, especially if this is blockchain related. The reason why blockchain we need a lot of testing to be carried on, because in blockchain, once it push out into productions, there's a lot of issues arise because the data are not immutable. That's why there's some blockchain that has some issue with just like the types error. So that's all for me for the video today. Thanks for watching. In the next video, I will be working on the WebSocket to make this blockchain decentralized, and then you'll see how it goes. Thank you for watching.